Swayam Prabha. Digital India. Educated India.
So, students, good afternoon. This is one of my most favorite topics, user-centered design. And we hear a lot about user-centered design when it comes to, online platforms, websites, online buying platforms, when you have these online shopping portals, because there, it immediately translates into business. Like when you sort of, somebody comes to your site, and if it's very easy to use and he's bought something on your site, if it's too tedious, they won't buy. So, coming from that angle, when I go and see my products which are around me, a lot of products are extremely tedious to use. Because of various reasons. Some reasons could be that they are because of legislation, some reasons could be because of material properties, and the people are not looking at how to make these products very comfortable to the user. So I'm talking about a physical product where helmets which are used on two-wheelers. So let me tell you a small story. I had this student, Mandar Kale, in 2007, I think, and he came late for a product design course. That is, we have a P2 project where he was late for a week. Then I asked him, Mandar, why are you so late? And what's happened? He said that his friend died in a motorcycle accident, and the motorcycle helmet was strapped to the back of the motorcycle. This was in Pune. And he was very disturbed because he was just saying that if only my friend would have put on that helmet, he wouldn't be dead, because he had a head injury. Head-on collision with a truck in the front, because the truck did a sudden brake and he was going at, So then, it struck me that, Mandar, if you're so concerned, can't we design a product where you're encouraged to use it? That is, you go like a way you take a key, you put on your helmet and you go. Can't we do such a thing? Why are helmets so uncomfortable? And then when we studied, we found out so many new problems with helmets and so many deaths. 140,000 deaths, in the year 2015. But if you go now, they're increasing, day by day. Now that the, fines are much more severe, people will wear helmets. But I'm just saying, why should the policeman ask for fines when you're saving your life? So this is the whole challenge we started with in this, journey of designing a helmet which will be extremely comfortable. But if you have an extremely comfortable helmet, will it be unsafe? Need not be. Very good. Will it not pass Indian standards? No, it has to pass Indian standards. Who is talking about today? We're talking about technology, materials and processes, and we have to make technology, we have to make materials, and we have to make our engineering process suit the user, right? Not give a manufacturer a specification that you have to make these helmets, like in this particular way, and there should be no ventilation, and if there's ventilation, the helmet will crack, which are not even justified for them to make. So we started with that premise and we said we have to look at the situation around us. Then this is one of my project associates in our design studio, Mr. Chari. He worked with us. He was also an MDes designer, and he said, "Sir, it's so complex. Our culture, our ecosystem, the way we use helmet, the way we use the two-wheelers, the way we use our two-wheelers." And he made this, wonderful, sketch, saying that our headgear, if you are having a headgear, what will you do? If you are having a, like milk, if you're a guy who's taking milk around, how will you handle? So we found it very, very challenging. So from there on, we started and we said, let us understand our culture. Let us understand the local situations and habits. And let us also look at the socio-economic condition. If the helmets are too expensive, nobody will buy, right? The helmets have to be, also looking at who is using the helmet for what purpose. So here we come down to a very important, topic in design, which is product planning. You need to have that variety of products which are suitable for different type of people. And it's a myth when we say that I have designed one product and it will be good for everybody. I take a good example of your spectacles. Everybody uses a different spectacle. Let it be style, let it be convenient, let it be a type of choice you have. Similarly, you need to have helmets which are that type of variety, so that you can choose the right helmet for your requirement. And we looked at, condition in India, become the largest two-wheeler manufacturer, still growing. 69% of the total number of motor vehicles are motorized. Injuries to the head are the main cause of death. And here, for example, you'll be surprised that when it's called a blunt injury, when the injury to the head happens, the brain goes and hits the skull inside, because the brain is in the fluid, and when it hits the skull, the person is brain dead. You won't see any injury outside, but the person is dead. So these are the challenging things we were facing, and we are saying that anyway, helmet is the most effective way of reducing these injuries. And the majority of two-wheelers, anybody we interviewed, we found out that they just don't want to wear a helmet. Then we went and started studying our market, our situations, and people. People is a very, very important study for us. And then we were watching the type of risks on the road. Risks are too many. What's happening when you're stuck at a traffic junction? The helmet gets very hot. Let us look at the construction of the helmet. What do you think saves the person's life in all these three parts of the helmet? The shell, the thermocol, which is the expanded polystyrene foam, and the PU padding inside. Out of these three, which is the one which saves the life? Thermocol. And that doesn't cost anything, right? Thermocol is the packaging. This thermocol has a special property of actually reducing the acceleration of the head, the brain inside, when it's going to hit the head. And that type of compression loading, we're not able to get in any other material till now. We tried a lot of options. We're not able to get that type of compression where you get that type of cushioning so that the brain doesn't go and hit the air. I must tell you a nice story over here. In Delhi, we were given a big task by the transport department, and they told us, please check out whether these roadside helmets are good or not. They're selling at 400 bucks, 600 bucks, 200 bucks, and they may be very dangerous for the people who are buying them. Then we took all the roadside helmets we have a very good biomedical facility in IIT Delhi when I was teaching there, and Professor Dinesh Mohan was the in charge. We got the studs helmets, which are the best in the grade. Then we got the other brands, 4 other brands, and we bought 4 local roadside helmets. And we put them on the testing machine with sensors and everything. And to our shock, the roadside helmets were performing much, much better, 20% to 40% better than the studs helmet. What could be the reason? More thermocol. And another interesting issue was that shell, which we thought was the most important, would crack in the other helmets and break, but save the life of a person. The roadside helmets didn't use that much resin as studs was using. So if you use a lot of resin, the shell is very hard. It takes when it goes and hits the floor, what happens? It absorbs less energy. Whereas the roadside helmet shell would go and crack. What happens when something cracks? Releases all the energy. It uses all the energy, and it was much, much better. That was a shock for studs. Their thermocol, the studs, when the thermocol in the studs helmet was actually 18 to 19 millimeters, and sometimes it was curvilinear because of the style and all. He had to make it some grooves inside. Whereas the outside helmet, no fancy design, it was straightforward round shell of 22 to 23 millimeter thick. That was the minimum. You need minimum 20 millimeter thick for saving the life of a person. It was 20 to 24 because it was just because of lack of things, and you want to make a simple helmet. Their EPS foam, which is the expanded polystyrene, was thicker and a uniform cross section. So it did very well in the field. So that gave us the impetus that we need to do something very drastic in making people aware of this, as well as see to it that people wear helmets. So then we said, let us study all the materials available. Where will use Kevlar, bulletproof, very, very high end. And then we also checked out other materials like Lexan. Lexan is a polycarbonate material. Polycarbonate is very strong again. Why should I study these high-end materials when I'm designing a helmet for a two-wheeler rider? I'm not going to use them. But by studying the materials, we study the properties. By studying the properties, I can come up with ideas for better use of material in my context also. So we always do that. Whenever we have some study, we'll study parallel products, whatever materials they're using, so that we can come back and do multiple work. So here then we also looked at ABS PC. This is a styrene material which is used in all plastic scooter parts. And ABS is a very good, ABS is acrylonitrile, butadiene, styrene, which is very easy to paint. It's injection molded. So just to, give you a little illustration of what happens if you're traveling at, say, 45 kilometers an hour and you have a head-on collision. It is like falling from the second floor balcony head down. That is the type of impact. And it's pretty severe. We don't realize it. And 45 kilometers an hour is nothing. Most of us go at 60 to 80 kilometers an hour. And if that is the speed, it will be like falling from the terrace of a 5-story building. There's no chance of survival. But after the collision, it drops. Here it is adding on. But if I come with a standstill truck, then my 45 kilometers become around 35 to 40 kilometers. By the time I go and hit because some amount of deceleration happens when I hit. Because some time of shock gets absorbed by the vehicle and then the movement of the body, all that. So it reduces a little bit. So, but then you can imagine that if the speeds are much higher, it could be very, very fatal. And that's what we see outside. So many deaths because of that reason. And that perception is not there. That is a challenge for us. And then we went and studied the standards. And a very interesting cartel happens with the standards. In the standards, we have people, we have professors, we have material experts, and we have also industry representatives. And unfortunately, they are completely biased towards manufacturing. They are biased towards technology, and they are not having any context of user convenience. And then all the helmet standards are coming from cold countries. They've taken the British standards and they brought that down. And all Europe, where do they use motorcycles? Racing, mountains, going. So for them, and whatever weather? Cold. Very cold. So what happens if you borrow the standards from them? Your head will get cooked in India, literally. And that's what happens in Delhi. When the temperature is outside of 47 degrees and you're wearing a helmet on your head, you just can't survive. It is so hot inside. So we went and we then met the Indian standards and we told them this is not right. You have to have a person who is responsible for comfort of a person in your committee so that they look at the comfort and then introduce all the new norms. Then we did a lot of observations of people's problems of, how they store their helmet, how difficult it is to buckle, and why people don't buckle their helmet. You know that they don't buckle the helmet, then what happens, tell me? The helmet flies somewhere else and you hit the head hit. So and we found out that at least 20% of the accidents are happening. People are wearing helmets and not buckling. It's happening because of that. That's also a very, very, serious concern of buckling up. So here we're looking at, it gets very hot and muggy. There was, people use a cloth inside, scarves, and, a lot of people, drive with the visor up, though it hurts their eyes, so that the air is blown inside the face. Or interaction between two people, extremely difficult when you wear a helmet. So that's a serious issue. How will you improve that? Then, it restricts vision is a very, very clear thing. Your helmet sizes are so big sometimes that it restricts the vision from the side. So this is the most important thing of our design process, the product brief. Here we're saying that the helmet should be easy and convenient to carry and store. Should encourage and stimulate use. Provide ample ventilation. Should be lightweight. Helmets are very heavy. That was a very important component which people did talk about. Should fit, aptly on the head without wobbling. A lot of helmets will be loose. And then provide clear vision and facilitate hearing and occupy less volume when not in use. So these are the briefs. So when you have a brief points, you want to now sort of work on these brief and make multiple ideas. Each problem should have an idea, right? Multiple ideas together will make a concept. Right? Multiple concepts will compete with each other to get selected as the best concept, and the criteria for selection will be the product brief. Got it? So let us see how this whole journey went. What is this doing? Buckling, because buckling by the side. You just move these levers and the helmet is not coming out anymore. And when you're doing ideas, remember, no questions asked, right? You did that creative brainstorming. So when the idea is there, respect the idea. Yeah, good solution. Wow, I love this idea. This is a scarf idea, and a lot of pillion riders, women riders would say that we are much more comfortable scarfing rather than buckling. Because buckling, a lot of people have fear that the buckle will not come out. Sometimes it rusts and the buckles are very difficult to pull out. So scarfing is a very common way of tying. And then tell me, if I put a scarf, what will Indian standards say? It's not secure enough. Very good. And what will they do? They will test the knot in the testing machine. They'll pull and check. Right? All that can be done by getting the type of fabric. But if you want to have an idea to go to the next level, you can always do whatever you want. This is an interesting sweat ring on the top because too much of sweat is coming. So there's a ring on the top for sweat. Another idea, again, Mandar only made all these ideas where you are receding sideways to make the helmet very slim and small. Again, two-part receding helmet. You pull them out and put them inside, so it becomes like very narrow, like a small file. This is again a collapsing, self-collapsing helmet. It is like all around, and the top it's got a net. Most of the protection happens on the side. This is like an interesting idea of swivel. You have two shells, you swivel and you lock, becomes very slim. All storage ideas, right? Side folding, right? This has been inspired by the sheikhs who wear this, round ring cap with the cloth. So it's been inspired by that, and it's like, ease of wear idea of it. Just should be as easy as wearing a cap or with a ring on the top. So there's windows on the helmet for letting air inside. So when you're at the signal, you can actually open the ventilation ports, or they can wing out the helmet so that you get the breeze needed. Then, inspired by various insects, different ways of sort of air ventilation so that your air, is you're very ventilated inside. Again, different type of dimples so that your air channels are formed, so your head is cool because of the Venturi effect. Slits from the sides if possible. This is a helmet with padding on the outside. Remember those people sitting next to each other want to talk? The helmet actually hurts quite a bit. A lot of people complain that they would dash against the helmet when the pillion rider wants to talk to the front because of the the padding on the helmet. So each problem, you need to come with an idea. Biggest challenge is pollution. So much pollution that if it's an integrated helmet with pollution mask, it can be fabulous. Again, if it's easy to store, very good. So we can think of a collapsible helmet. And then these are only very few ideas I showed. We had some 150 ideas. I'll show you some of the clusters. So what happens when you have a lot of ideas like this? You very clearly, we are coming down to the first 3 points which talk about comfort of use, encouragement of use, and ventilation, right? So automatically when you cluster ideas, these type of situations will come forward to you. So we had a ventilation cluster, that is I put all the ideas which talked about ventilation as a ventilation cluster. I put all the ideas on the board. We actually do allotting, which was the storage cluster, easy to store cluster, and all the ones where it's easy to wear. We talked about motivation and less resistance to use a helmet, that we put in the ease of wearing cluster. Look at this ventilation cluster. This was put in this cluster because it has chance of ventilation also. This was going to the folding cluster. So you can actually bring a couple of ideas together. Look at the window idea, look at the gaps, look at the ventilation. A lot of ideas are put together, and then what you do is you actually use all those ideas. For example, these slit ideas were also used. The louver ideas also were used inside for the thermocol. The ideas where you are opening, remember that side openings were also used. So when you build an idea, you use the other ideas as your inspiration because you cluster them together. Then we chose that as the champion idea. So how will that happen? That's called amalgamation and building up of an idea into a concept. So you're building this idea into a concept now. So this idea, then you start working on this. It's too open, so I need to close it in. I need to close further in, and we check up the areas which is not covering. Bring those areas in, and then you make a helmet which has all the features. And look at the strap. There's no buckle there. That is the most innovative point. The strap is done using an elastic. Okay, so here we have concept A, and the concept A is personifying ventilation, right? But it's a full concept. It's got all the features which are built in.